Hi. I'm Dr. Kelly, and this is your college algebra class. So, a couple of things before we get started. You will be given a silly phrase during the lecture. Right now, I'm going to be really obvious about it until you kind of catch on, but that is the phrase that you'll put into your attendance quiz on D2L. Now, don't worry if it auto grades and gives you a 0. Just put in the phrase. Sometimes it doesn't like, who knows, whatever. I mean, it's really, really picky. I don't understand it myself. Sometimes it grades 100% on something, and then on the next person, it'll grade it as a 0. But what I want to tell you is I go back in and I go through and I review all of those grades. So don't worry if it gives you something other than the grade that you desire, which is 100, of course. Okay, so, and if you have any questions whatsoever, please feel free to send me an email. Please put the course you're in the subject line or at the minimum somewhere in the body, because I have a lot of students this semester and it's early in the semester and it's very difficult for me to know what class you're talking about. All right, so let's get started. I expect that today's class may bore you a bit, and that's okay. This is where we are. We're just setting those foundations for the bigger algebra ideas that we'll be dealing with. So this is Unit 1, the very first section here. We're going to talk about solving linear equations. Again, like I said, might bore you to tears a little bit, but hopefully I'll show you something in here that you didn't see before. All right, well, let's start off with a linear equation. It is an equation that can be manipulated to have only one instance of a single variable, okay? Meaning that there's no powers on that letter. There's no squares, there's no cubes, there's no square roots, there's nothing else happening to the variable, just the variable. And the answer is called a solution. It can also be called the root. Okay, and the official form for a linear equation is ax plus b equals 0. And these standard forms are always set equal to 0. And this plus could be plus a negative number, but just for ease, we always default to a plus sign. So just real quickly here, let's solve this equation. Of course, the thing that we know is we've got to move the addition and subtraction away. If you go ahead and start dividing everything by 3, here it would turn out nice, but relatively rare does it come out very nicely. So first we need to move all of our addition and subtraction. The idea is to get all the variables on one side and all the constants on the other. Now, I don't really care which direction you go, but I am going to suggest since y'all are in college algebra, that tells me that you're going to take more math. I'm going to suggest that you go ahead and make a habit of bringing all your variables to the left and all your constants to the right. And I'll be modeling that because that's the way that I'll do it. And of course, the very last step when you're solving an equation is to do the division, because you don't want to deal with all the nasty fractions, right? Okay. So I did write out a few steps here. Some people like steps. So we've got the steps to solve linear equations. And remember that the main goal is to isolate that variable to one side of the equation. Now, if you have any fractions in your equation, unless you really, really enjoy fractions, you're going to want to clear those out. So we'll do an example or two like that. So if there's fractions, you want to clear that out first. And also remember that you always have to distribute and get rid of parentheses and stuff before you can solve something. And then the main idea again is to move all the variables to the left of the equal sign and all the constants to the right by using those opposite operations. Remember, when you go from one side, the equal sign, to the other, you do the opposite of the operation. And the last thing I want to remind you of is that of all the things in the world, algebra is like one of the only things that's truly fair. So what you apply to one side of the equation, you must always apply to the other side. Okay? All right. Well, let's just keep on going here. Let's just do a few examples, shall we? So let's take a look at this first example here. Remember what I said, I like to move all my variables left and all my constants right. And so I'm going to subtract 7x from both sides here. And I'm also simultaneously going to add 4 to both sides. Okay. So I get here negative 5x is equal to 9. And then we're going to divide both sides by that negative 5. And you don't have to show me all these steps. Um, but if I can't follow your math and you have magic, or if it's something that I need to write down, then I'm going to expect you need to write it down as well. Okay, let's look at this next example. So this next example's got those fractions in it, and I want to point something out first. So this is exactly the same. And I want to point that out because a lot of times students struggle a little bit with that, and you're going to be seeing a lot of fractions moving forward. So we really need to just knock it out right away. Now, if I rewrite it like this, you can clearly see what the denominators of everything are. And you can also see that this 1/2 is applied to everything in this x plus 5, and this 1/3 is applied to everything in this 2x minus 3. Now, the denominator of this 4, I'm sure you know, but I'm just going to write it down, is 1. All right, so the thing we want to do to clear the fractions is we want to find the LCD, okay? And it doesn't even have to be the lowest common denominator. It just has to be a common denominator. And this one is pretty simple to see, but I'm going to tell you that the best way to find the LCD is to write the first denominator down completely. Look at the next denominator through, add it in. These are all going to be multiplied. And the final denominator, if it isn't already on the list, needs to be added. Okay, and I know you're like, oh my God, I hope she doesn't do this all class, but I will tell you that this simple idea here is what we're going to apply to much scarier looking problems. Okay, so I just want to make sure everyone understands what I tell you. Now, what I just said a couple of minutes ago was one of the only things that's fair in the whole wide world is algebra, right? And what you do to one side of the equation, you have to do the other. And in turn, what you do to one term in the equation, you have to do to every term in the equation. So I'm going to go ahead and multiply all these pieces by 6. And then I'm going to clear out the fractions. And look, if your fractions don't go away, you screwed up on your LCD, right? And then that cleans up to this problem now. 6 times 4. Now, one thing you'll learn about me is my arithmetic is pretty awful. So, it's all those calculators, all those years, right? So let's see, 3x minus 9 is equal to 4x minus 2. If we were in the classroom, I'd tell you to holler if you see me make a mistake. Now that we're not in a classroom, that makes it a little bit harder. So I'll try to be a little bit more careful. Okay, so here's where we are. I'm going to add that 9 over. We get negative x is equal to 7, and this isn't solved for x, right? It's solved for negative x. So we're going to divide both sides by -1, and we get x is equal to -7. All right. Okay, so let's look at the next example. And it's got parentheses. This gives us a great opportunity to make sure everyone remembers how to multiply two binomials together or a binomial to a trinomial. Remember, everything in the first parenthesis has to multiply to everything in the second parenthesis. All right. So, and there's a method I know you're aware of called the FOIL method: first, outer, inner, and last. Okay, so let's multiply this up together. 2y times y is 2y squared. 2y times -1, -2y. Y times 1 is a y. 1 times -1, -1 equals y times 2y, 2y squared. Because y times y is y squared, minus 5y plus 10y minus 25. And now I like to take the time to clean up either side before I do anything else here. So I'm just going to clean up each side. And now you may notice here that we've got the exact same thing, 2y squared and 2y squared on both sides of the equal sign. So those are going to cancel out. Now, if you don't see that they'll cancel out, you can think about subtracting one of them over and they will cancel out. So let's see what we're left with here. Looks like we need to subtract a 6y from both sides and add a 1 to both sides. See what we've got there. Minus 7y is equal to, I don't know why I subtracted a 6y. That should be a 5y. My brain did the math there. This should be a 6. Let me just get my eraser here. And over here we have -24. And then we'll divide both sides by -6. And we will have y is equal to 4. Okay. Ooh, that changed quickly now, didn't it? Oh, yeah, but it's the same idea as what we did up there when we had a fraction. The first thing we need to do is clear the fraction, and to do that, we need to find our LCD. And like I said, the best way to find the LCD is to write the first factor completely, just whatever it is. Okay, and then we're going to do subsequent. That means the next one, right? Subsequent, not already listed. Okay, that's the idea. All right, so here for our LCD, I'm going to write the first denominator down fully, x minus 2. When I look at the next denominator, it says x minus 1. I do not have an x minus 1. I have an x minus 2, so I'm going to need that x minus 1. And then when I look at the third denominator, it has an x minus 1. I already have one of those. It has an x minus 2. I already have one of those. That is our LCD. Okay, now we're going to multiply each piece by that LCD. So we're going to go x minus 2, x minus 1 times this first piece, 3 over x minus 2, equals x minus 2, x minus 1 times this next piece, 1 over x minus 1, plus x minus 2, x minus 1 times 7 over x minus 1, x minus 2. All right, so I did the same thing I did up there with that whole number, but this just looks a little bit crazier. And now we're going to cancel here. So we have 3x minus 2 cancels with that 3x minus 2. This x minus 1 cancels with this x minus 1. And this x minus 1 cancels with that one. And this one cancels with that one. Remember, they're kind of kitty corner because these are all over 1 here. All right. So let's see what we're left with. We're left with 3 times x minus 1 is equal to 1 times x minus 2 plus 7. All right, so let's clear these parentheses first by distributing. I'm going to come this way. I'm going to clean up that other side here. We have 3x minus 3 is equal to x plus 5. And now we'll subtract our x's and add our 3's. And we get 2x is equal to 8. Divide by 2. X is equal to 4. Now I want you to pay notice to something I wrote down here. When we solve rational equations, and that's what this is, a rational equation is an equation with a variable in the denominator. Okay, so let me write that down. So a rational equation has a variable in the denominator. Hold on. In the denominator, sorry, I got a phone call and now I got to get all back together. N-O-M-I, I can't denominator, D-E-N. If there's a variable in the denominator, then it is a rational function. So something like x minus 3 over 5, not rational. Okay, that's not considered rational in the algebraic sense. But 5 over x minus 3 is rational. And that's what I mean. So if you have an equation that has a variable in the denominator, then after you get the solution, you have to check. And the way you check, you don't have to stick it in and check the whole thing. You just check to be sure that the solution, I'm going to call it a root because it's a few less letters to write, that the root does not make the denominator equal 0. All right, and so we can check here. We have x minus 2, so if we get 4 minus 2 is not equal to 0. We don't care what the number is, it's just not equal to 0. And we have x minus 1, and 4 minus 1 is also not equal to 0. So this is our solution, okay? So that's the one little extra step you have to do, whether we're dealing with linear equations or quadratic equations or whatever. If it starts off like a rational, you have to check the solution. Other than that, I'm going to assume that your algebra is pretty straight. If you need to check, you can always plug in the answer that you get and make sure you got an equivalent statement. Okay. So let's look at some applications of linear equations. So here is a very common application. And anytime you see the word application from me, know it's a word problem. There will be plenty of them in this class. It's part of the gig, okay? So applications of linear equations. The equation C is equal to 5/9 F minus 32 gives the relationship between Fahrenheit and Celsius temperatures. Finding the corresponding Fahrenheit readings given the following Celsius temperatures: 0, 10 degrees, and 27 degrees. Okay, so we could plug in 0 and solve this equation for f, but we want to kind of work smarter, not harder. So what is this actually asking us to do? It's asking us to find f when c is equal to whatever. Okay? Now, right now, the way the equation is set up, F, Fahrenheit, is kind of what we would call the input, the independent variable, the one that drives what the answer is, okay? And C is right now considered the dependent variable. It is depends on what F says on what C turns out to be, okay? That makes sense. Now, in this situation, since we're looking to find F when we're given C, we need to solve the equation for F. Right now, this equation is solved for C, and we need to take this equation and turn it around and solve it for F. And so we're going to take our C is equal to 5/9 F minus 32. Okay. Excuse me, we're going to follow the same directions that we followed for solving that equation. This is called solving a literal equation. That's what we're doing here, is we're going to solve it literally. And we're going to get the F by itself. So the idea is this is our prize. We want to keep our eye on that prize. We want to get F by itself. Now, the very first step in solving a linear equation is to get rid of the fractions, right? So we need to figure out what the LCD is. And the LCD is 9, because that's the only denominator it is. This is over 1, and all of this side here is actually over 9, as I showed you before. Remember, this is the same as saying 5 times F minus 32, all that crap over 9. Those are the exact same thing. Okay, so the LCD is 9, so I need to multiply this one piece, because remember, it's all just one piece. If I write it like that, and I need to multiply this one piece by 9. Okay, now you might be asking, Dr. Kelly, why didn't you multiply the F by 9 and the negative 32 by 9? And it's because this is all one piece. Okay, so 5/9 F minus 32 is the same thing as writing 5 times F minus 32 over 9. Or, I mean, we could write it like this, 5 times F minus 32 over 9. All these are the same thing. Okay, so now we can cancel these two 9s out. And what our equation now looks like, oops, sorry about that, is 9C is equal to 5 times F minus 32. Now, also in those directions was to get rid of parentheses, but I need you to take a notice here that the operation going on between 5 and F minus 32 is multiplication. So since we're just trying to get F by itself, just trying to get this by itself, I am actually going to divide both sides by 5. Okay? And so that's going to give me 9/5 C is equal to F minus 32. Now look, we're super close. We just got to get F by itself. Okay? So now we'll just add that 32 to both sides. And I'm going to change the order because I like to have the dependent variable on the left and the independent variable on the right. So we have F is equal to 9/5 C plus 32. Okay, and now this is solved for F. Just like this one here was solved for C. Okay, same equation. We used algebra. We manipulated it so we could work smarter, not harder. We still could have done it the other way, but this way, we're just going to plug in a number and get an answer. So let's see what we have here. When Celsius is equal to 0 degrees, we have F is equal to 9/5 times 0 plus 32. F is equal to 32. When C is equal to 10, we've got F is equal to 9/5 times 10 plus 32. So F is equal to 5 goes into 10 2 times. So 18 and 32. This is my, let me just use my calculator. There's no shame in the game. 18 and 32 is 50 degrees. And then finally, Celsius when it's 27 degrees. This one's not going to be pretty, is it? 9/5 times 27 plus 32. Now here's the question. To calculator or not to calculator? Definitely calculator. Okay. All right. So we've got 9/5. And if you do not have a calculator yet, you will need one. Okay. Um, Not necessarily this week. Other than maybe to do a little bit of math, like arithmetic, but you'll definitely need to have that calculator. Now, you can go by the library on campus and rent one. You definitely want a TI, either an 83 or an 84, whichever one, it doesn't matter. But also, when we start using the calculator, I will use an online emulator of that calculator so you can also use that as well when time comes, but it's really nice to actually have a calculator in your hand. So you can rent them for the semester and it's free. You just borrow it from the library, but please heed my warning that you will definitely need a calculator. Okay, let's take a look at another application of linear equations. Now, this is the key here, and the key is the word linear. And what the word linear means is, sorry, only one variable. Okay, so you have to take note of that. Now let's read the question. Hold on a minute. Try to kill this frog in my throat. A total of That didn't help, did it? A total of 18,000 was invested in both stocks and bonds. If the amount invested with bonds is half that invested with stocks, how much was invested in each? Okay, so, oh, I think I got it. Okay, so sorry about that. So we have two things here. We've got stocks plus the bonds equals 18,000. Okay. And let's just call stocks S and bonds B. Just keep it easy. So our first equation is S plus B is equal to 18,000. Now I told you because it's linear, we can only use one variable. Therefore, you have to find the relationship between the two variables. And those are going to be math words, right? It's going to be uh, more than, less than, times, double, triple, half, a quarter. Those are going to be those words that are going to give you the indicators on how you can actually put these two variables together. So let's go back here and let's look. It says if the amount invested with the bonds is half that invested with the stocks. So bonds equal stocks in half, right? Which is 1/2 of stocks. Okay. So now our equation can be stocks plus 1/2 stocks equals 18,000. All right. And now we only have one variable. And when we have one variable, we can solve it. So here's the deal. You can only solve an equation for as many equations as you're given in a pair for the number of variables. So one variable, you can solve it with one equation. You got two variables, say X and Y, you have to have two related equations to be able to solve that. If you have 5 variables, you have to have 5 related equations to solve that. So that's kind of like the idea. Okay. Now, first things first, and you'll know this about me, and I do really enjoy fractions, but I do not enjoy messing around with them. So I'm going to multiply everything through by our LCD, and our LCD here is 2. Okay, so I'm going to say 2 times this guy, 2 times that guy, and 2 times that guy. I'm not doing it on either side this time because it's not a side-to-side thing like in our previous examples. There's just one term in the equation that has the fraction. So I need to just deal with that one. Okay? Now, remember, what you do to one side of the equation, you have to do the other. And also, if you do it to one single term in the equation, you must do it to every single term in the equation. And that is what we did here. All right. And so we wind up with 2s plus s is equal to 36,000. So we have 3s is equal to 36,000. And dividing by 3. S is equal to 12,000. Now, if I give you an application problem, if I give you words, I need words back, okay? So I need you to give me your solution in words, all right? And it says how much was invested in each. Stocks, 12,000, right? And the bonds are equal to the 12,000 divided by 2, which is 6,000. Now, do you have to show me that work? No, you could just tell me and make sure it's very clear because that's what I asked for, but don't make me hunt for it, right? And be sure to read the question because you would have only gotten half of the credit if you had not given me both of those answers, stocks and bonds, because I said how much was invested in each. All right. Let's keep on going. I think we're almost done. Yes, this is the last one, which is good because my computer is about to die. Again, we have linear equation, which we know means we're only going to have one. Hold on a second. Before I stop, let's do today's silly phrase, okay? And I do not usually write the silly phrase down. Doesn't mean I won't do it a few times, but I don't usually write the silly phrase down. But today, the silly phrase is my socks disagree today. Okay, that's the silly phrase. That's what you'll put in the attendance quiz for your 1.1 lecture. Okay, back to this question. It says Shannon grossed $928 a week working 52 hours. Her employer pays time and a half for hours over 40. With this information, what is her hourly wage? Now, what I did is I set up a table, right? Because we know we got regular time and we got overtime. Okay. And regular time is 40. And the overtime was 52 minus 40 because it was over the 40. And we don't know what the wage is. I mean, we don't know what the wage is, so we don't know what the rate that they're getting, but we know when they pay overtime, we get time and a half. So if we multiply these guys together, we get 40x, and we multiply these guys together, 12 times 1.5. Now let's see what that is here, 12 times 1.5. So our equation is going to be 40x plus, I don't know why I wrote that. I don't need to pay attention to that, times 18x is equal to $928. So we have 58x is equal to 928. Divide by 58. And we get x is equal to 16. So her rate is 16 an hour. Okay, congratulations. You made the first one, and me too. Y'all have a good day. I remember how